Sorghum probably originated in North Africa around 3000 years before Christ. It was certainly being cultivated in Egypt in 2200 BC. It then spread throughout Africa and subsequently to India. In India, it is known as sorghum belongs to the family Graminae. It is classified depending upon certain qualities and uses. They are grain sorghums, known for kernel quality and size; sweet sorghums, known for stem sugar content and forage quality; broom corns, for length of branches suitable for use as brooms and brushes; and grassy sorghums for forage. All these cultivated sorghums are scientifically called Sorghum bicolor. Grain sorghum is a nutritious coarse cereal. The plant bears panicles containing around 2000 seeds per panicle. In our country, sorghum ranks 4th in area and production after rice, wheat, and maize. It is grown in Kharif and Rabi. Occasionally, it is grown as summer crop. During the year 2003-2004, grain sorghum production in our country is 7.73 million tons. Out of this total production of 7.73 million tons, 5.01 million tons are produced in Kharif, 2.23 million tons are produced in Rabi. Out of the total production, 65 to 70% is utilized as human food, 20% is used as poultry feed, 8% is used in dairy feed, and 2% is used to produce industrial alcohol. Sorghum constitutes an important crop, forming a large part of the human diet and the chief food grain in Maharashtra, Karnataka, and some parts of Andhra Pradesh, Gujarat, and Madhya Pradesh. Sorghum is consumed in our country as roti, or unleavened bread made of flour. And to a small extent as sankati, a thick porridge made from coarse flour grits. Sorghum crop is often referred to as a poor man's crop, as it is widely perceived as a crop produced and consumed mainly by middle and poor class people. However, of late, it is gaining importance on a limited scale as a health food, greater use as quality forage, and as an adjunct in feed mixes. Sorghum rotis are now a delicacy and favored dish in star hotels and also on roadside kiosks. Grain sorghum has 9 to 11% of crude protein, 1 to 2.8% of fat, and 60 to 69% of carbohydrates.
The National Research Center for Sorghum, or NRCS for short, is the nodal agency in the country which deals with all aspects of sorghum research and development. We also coordinated a national network of sorghum workers located in 16 different centers all over 10 states of India. This center was established in 1987. However, sorghum work started here as a part of the PIRCOM center established in 1958. Later, it became a branch of IARI, Indian Agriculture Research Institute, before NRCS was established.
Let us now look into various aspects of sorghum production technology. The right season for sowing Kharif crop is at the time of the onset of monsoon, which is generally from the last week of May to the second week of June in South India. In North India, it may be sown even later. In case of irrigated, multi-cut forage crop, it may be sown even in summer before the onset of the monsoon. For Rabi crop, mid-September is ideal for planting. In case of soil moisture availability, the planting can be extended up to the first week of October. For low rainfall and light soils, early duration varieties like CSH6, CSH14 and CSH17 are chosen. For normal rainfall area, all the varieties such as CSV13, CSV15, SPV462 and hybrids CSH9, CSH14, CSH16, CSH17 and CSH18 are suitable. While selecting the seed, utmost care should be taken to select bold and healthy seed. The quantity of seed required to sow in an acre is 3 kgs or 8 kgs per hectare. However, for Rabi crop, an additional quantity of 2 kg seed should be taken for a hectare. The field selected for raising the crop is made ready by ploughing thoroughly with bullocks or tractor at least twice to obtain a good tilth. Farmyard manure at the rate of 10 tons per hectare should be added during the last ploughing. The land is then levelled to facilitate cultural practices and also for intercultivation. Sowing the seeds in regular rows with a space of 45 centimeters between the rows is recommended. While sowing, care should be taken to space the plants in a row with an optimum distance of 12 to 15 centimeters between the plants. By such spacing, the optimum plant population of 1.8 lakh plants per hectare will be achieved. In Rabi, the space between the rows should be around 60 centimeters and the space between the plants should be 16 centimeters, bringing the plant population to around 1.35 lakhs per hectare. However, under irrigated conditions, the optimum plant population is 1.5 lakhs per hectare, obtained by maintaining distance of 45 centimeters between the rows and 15 centimeters between 2 plants in a row. Basal application of fertilizer at the time of planting is very essential for getting a healthy crop. 40 kg of nitrogen and another 40 kg of phosphorus are applied at the time of planting. Weeds damage the plants right from the seedling stage itself. So, in order to discourage the weeds attacking the freshly emerged seedling, atrazine at the rate of 0.5 kg active ingredient per hectare should be sprayed on the soil soon after planting or at least on the next day. This pre-emergence weedicide application keeps the crop free from the weeds for a period of 30 days. Germination usually takes 4 to 5 days. Due to manual planting, seeds fall very near to each other and germinate. In such cases, thinning of the plants should be done, preferably 14 days after germination, after shoot fly attack. Thinning involves removal of some plants to maintain the optimum distance between 2 plants in a row. For proper growth of the plants, additional nourishment is needed after 30 to 40 days of planting. 40 kg of nitrogen is applied depending upon the moisture availability in the soil. While applying the fertilizer, care should be taken to ensure moisture availability in the soil nearer to the base of the plant. After application of the fertilizer, the area should be covered with the soil. Growth of the crop should be monitored constantly. Intercultivation should be done after 30 days of planting. This can be done either manually or by any mechanical means like tractor fitted with cultivator or blade harrow. Such an operation not only helps to check the weed growth but also helps to conserve soil moisture by providing soil mulch. Though no irrigation is required during the normal Kharif season, Rabi crop can significantly benefit from irrigation, especially if sown on shallow soils or if soil profile is not fully changed. In medium deep to deep soils, 3 irrigations are desired. Irrigation needs to be given at the time of germination, panicle initiation, and at the time of grain filling. In case of limited availability of irrigation water, irrigation is given at the time of either flower primordial stage or boot leaf stage, depending upon the soil moisture availability. As the planting of sorghum crop is done in rows, the free space between the rows can be effectively used by intercropping. Intercropping with legumes like red gram, green gram, etc. that fix atmospheric nitrogen, supplement nitrogen to sorghum crop, and maintain the fertility of the soil. Pulses thus produced from intercropping supplement nutritional needs of the farmer. Intercropping also helps in reducing the incidence of pest attack. Many insect pests attack the crop from very early stage onwards. Some of the major insect pests are shoot fly, stem borer, sorghum midge, and earhead bug. Shoot fly adult is a small, grey-colored fly which deposits small, white, cigar-shaped eggs on the undersurface of the seedling leaves. Eggs hatch into larvae. They enter the seedling through the wall and feed on the growing tip, causing wilting of the leaf and later drying of central leaf, giving a typical appearance of dead heart symptoms. If the infestation occurs a little later, damaged plants produce side tillers, which again are infested, increasing the population of the pest. Finally, the whole plant dries up and dies. The population of these pests is normally very low in April to June, tends to increase in July, and reaches a peak in August. From September onwards, the population gradually declines and remains at a moderate level till March. Shoot fly can be avoided by suitable adjustment of the planting time. If plantings are done within 7 to 10 days of the onset of the monsoon, the crop can escape its damage. Another important cultural practice is to increase the seed rate and destroy the dead heart seedlings after removal to maintain the optimum plant population. In addition to these cultural practices, application of chemicals can effectively control the onslaught of this pest. Carbofuran 3G or 4810G at the rate of 20 kilos per hectare at the time of sowing as soil application in the seed furrows effectively checks the pest incidence. Stem borer is a medium-sized and straw-colored moth. The larvae of this moth feed on the upper surface of the wall leaves, leaving the lower surface intact as transparent windows. As the severity of the feeding increases, punctures and scratches of epidermal feeding appear prominently. Subsequently, the larvae bore into the stem, resulting in extensive stem tunneling. Sometimes dead heart symptoms are also developed. Uprooting and burning of stubbles prevent its spread from one crop to the next crop. Effective control of the borer can be achieved by placing granular or dust formulations in the wall. Carbofuran 3G or endosulfan 4G or 4D or carboril 3G or malathion 10D at the rate of 8 to 12 kilos per hectare if applied at 20 and 35 days after sowing, controls the borer. Sorghum midge is a tiny, fragile orange color fly which can be seen hovering on panicle top in early hours. The larvae of this insect feed on the newly fertilized ovary of the flower, thereby preventing kernel development. One of the effective cultural practices to avoid the midge infestation is to plant the crop early June. Destruction of chaffy panicles and earhead residues will restrict the spread of this pest. To control this insect pest, 6 grams of carboril 50 SP is mixed with 1 liter of water and sprayed at the rate of 500 litres per hectare. Alternatively, dusting with endosulfan 4D or carbaryl 3D at the rate of 20 kilos per hectare once at the pre-bloom and again after 4 to 5 days can effectively check the midge infestation. Earhead bug adult is yellowish green in color, 5 mm long and 1 mm wide. Nymphs and adults suck the sap from flower contents, resulting in weakening of the plant, reducing the grain weight, quality and seed viability. Early planting reduces the chances of flowering period coinciding with peak pest activity. 6 grams of carbaryl 50 SP is mixed with 1 liter of water and sprayed at the rate of 500 liters per hectare. Alternatively, dusting with endosulfan 4D or carbaryl 3D at the rate of 20 kilos per hectare once at the pre-bloom and again after 4 to 5 days can effectively check the infestation. In addition to these major insect pests, sporadic pests like shoot bug, aphids, mites, panicle worm and pyrilla also damage the crop at various stages. In addition to appropriate plant protection measures, crop rotation with leguminous crops and sequence cropping with oilseeds and fodder crops will reduce the pest incidence. One of the major threats for Kharif sorghum is the blackening of grains due to rains at the time of panicle formation and maturity. Blackened grains or moldy grains are unfit for human consumption. However, helps in removing the infected black surface of the grains.
To increase the profitability of the grain and marketability of the grain, we advocate this pearling machine. This pearling machine, like in rice and other crops, it polishes the grain.
Pearling also helps in value addition and is liked by consumers because of pearly white, shining appearance. Blackened grains, though not utilized for human consumption, are extensively used in poultry feed mixing, animal feed mixing and alcohol industries. The right time of harvesting is when the crop is at physiological maturity.
The right stage is when we get a black layer, backside of the seed we get a black layer. That means the panicle is ready for harvest.
Depending upon the variety, it takes 30 to 35 days after flowering to attain physiological maturity state. This stage is recognized by formation of black spot at the back of the seed. Harvesting is done manually using rickets. While harvesting, care should be taken to cut the panicle with the stalk not more than 2 to 3 centimeters below the panicle. After harvesting, the panicles are collected and dried either by sun drying or by using dryers. Grain sorghum produce is stored by farmers in gunny bags, bamboo baskets, and metal bins. Grains are susceptible for attack by various insects. In order to control these insects, farmers often mix neem leaves, ash, or fine sand. All these methods have limited effect for a very little time. A low-cost, non-chemical method of disinfesting the grains was developed by ICAR-IIMR, Hyderabad. Sorghum crop can be utilized in many ways. Sorghum grains are used for human consumption. They also form an important ingredient in poultry, cattle and animal feed. Sorghum flour is utilized in making beer. Sorghum flour can be used for making bread, biscuits and cakes. Stem portions of sweet sorghums are used in preparation of jaggery, alcohol and syrups. National Research Center for Sorghum at Rajendra Nagar, Hyderabad in Andhra Pradesh has done tremendous crop improvement and its utilization. The commitment, dedication and research of the scientists lead to the development of various high-yielding varieties and hybrids suitable for farmers and industrialists.
This is CHS 16, one of the nationally released hybrids. It's very much suitable for intensive cultivation as well as for intercropping. Look at these semi-compact panicles. If it rains too much, then extra water can just slip away, thereby it will avoid mold. It is also innate ability to resist grain molds and give you high quality plump grains which will fetch higher price in the market. This is another nationally released hybrid. It is called CSH 17. It's early, so it can be grown even in Rajasthan, and its quality also is quite good, and it matures much before the season ends. Most farmers want both high grain yield as well as the stover for their cattle. That's why we have released yet another hybrid called CSH 18, which gives high grain yield as well as lots of fodder. This is very much suitable for the black soil environments where the rainfall is high and where farmers want to go for sole sorghum crop. Nowadays, sorghum is becoming very popular as a biofuel crop. Sorghum such as like this one, which are called sweet stalk sorghum, which are stalks like this, which can be eaten or chewed, can produce lot of juice, and from this juice we can produce alcohol which can be later on mixed with the petrol, and this will be very economical in the days to come. Using the tools of new biology, we can overcome the sexual barriers. For example, here is a plant which is a cross between sorghum and sugarcane. From this we want to derive plants which will have the best qualities of both. For example, we can derive the shoot fire resistance and high sugar accumulation traits from sugarcane and introduce to sorghum. And sorghum can contribute red rot resistance, for example, to sugarcane. For every rupee spent on sorghum research and development, the country is reaping a benefit of 40 rupees. I think it's a tremendous achievement. However, we are not resting on our past laurels, because you've got a much greater challenge to face now in this era of competition for not only producing the crop but also selling it, and then attracting funds to continue our research.
Seed production technology has been developed for all hybrids. As a result of their relentless efforts, productivity of the crop has also increased from 500 kgs per hectare to 1005 kgs per hectare. This is not the end of the road for NRCS scientists. The research goes on and on and on to make sorghum as important a crop as wheat and paddy in our country.